Alright, so quickly doing the derivative of this function. So this is from the review set. Find the gradient of the tangent to y equals tan 2x at x equals pi on 6. So we're doing our derivative first. So dy dx. Now this is a chain rule here. So we're going to go, it's going to be tan 2x, sorry, not tan 2x, the derivative of tan 2x, which will give us 1 over cosine squared 2x, and then times the inside of the chain, which is the 2. So it's going to give us 2 over cosine squared 2x. Now, we've got to find the derivative at this point. So we're looking at, sometimes it can be easier to write this as 2 over cosine 2x, and then that's all squared. It just means if we can solve cosine 2x, then we're all good. Now, if we have cosine 2 and x is pi on 6, hey, let's just jump down a line. So getting ahead of myself. So now we're looking at dy dx at x equals pi on 6. So this is going to be 2 over cosine 2x all squared. Now, I'm going to get rid of the x and I'm going to swap it out for pi on 6. Okay, now, you'll notice 2 times pi over 6 is going to be pi on 3. So we can go, well, that's going to be 2 bracket cosine pi on 3, and that's going to be all squared. Now cosine, if we remember our SOHCAHTOA, cosine is for pi on 3, so pi on 3 is our angle up here, is going to be adjacent over hypotenuse, so this should be 2 over a half squared. Alright, so then that's going to be 2 over 1/4, because 1 squared is 1 and 2 squared is 4. All right, and then this will be 2 times 4 over 1. So our slope at that point is going to be equal to 8. All right.